So today we're going to talk about the derivatives of logarithmic functions. So this is like the last basic derivative that we have to deal with. And it's actually fairly simple. If you want to take the derivative of the natural log function, your answer is simply going to be 1 over x. And of course, this is great, but as in most type of problems, you're not going to simply have the derivative of the natural log. You're going to have something else. So we need to be able to generalize just a little bit. So a generalization, and we're going to do this for both logarithmic and exponential functions. The exponential one we've actually already seen before. If you take the derivative of e to the power of some function, what you do is you just take the derivative of the exponent and put it on the outside, and then just copy what you already have, e to the power of that something. And this is just something that we've already seen. It is the chain rule, so there's nothing special going on. And for logarithms, it's a very similar type of thing. Again, this is just the chain rule, so if you look at the chain rule and how that's applied, this is going to be the same thing. If you have the natural log of g of x, you just take the derivative of that and then divide it by the original function. So let's do a couple examples here. So suppose I want to take the derivative of the natural log of this particular function here. The rule is we simply take the derivative of this function. So and when I say this function, I mean just the inside part here. So I look at my inside part, which is going to be 6x. And we know that the derivative of negative cosine is going to be positive sine. So we're going to put plus sine x. And then we divide it by the original function. So that's going to be 3x squared minus cos x. And that is our answer. You will notice here that the natural log does not appear in this at all. Okay, so it's a little bit different than some of the other functions. It's actually, I suppose it's similar to what we did with inverse trig functions, that the inverse trig function does not appear in the final answer. It's kind of the same thing with the natural log. The natural log does not appear in the final answer. And then just to practice another one that involved e to the power of something, if I've got e to the power of 2 tangent x, what we do is, again, we just look at this inside function, which is 2 tangent x. We take the derivative of that, which is going to be 2 secant squared x. And then we multiply that by e to the power of whatever is already there. So we make no change. And again, this just follows directly from the chain rule. So one more generalization that we want to consider, of course, is other bases. So far we've dealt with the derivative of e to the power of x and also the derivative of the natural log of x. These are all base e type of problems. Remember, e, of course, is about 2.72. And remember that when I have a function y equals the natural log of x, this is just the inverse function of e to the power of x. So we could say that if y is equal to natural log of x, then x has to be equal to e to the power of y. So what if it's a different base than e? What if it's 2 to the power of x or 5 to the power of x? Or what about if it's a logarithm that is not a base e logarithm? Remember, this is also the base e logarithm. Well, what do we do in those particular cases? Well, if we have the derivative of b to the x, this is just going to be the natural log of b times b to the x. And then, let's create some room over here. If we have the derivative of the log base b of x, that's going to be the 1 over the natural log of bx. So that is our generalization here. And then just to do a couple examples, if I want to take the derivative of 4 times 5 to the x, really all this is going to be is we can just keep the 4 outside. This will be the natural log of 5, and then 5 to the power of x. So really, it's just the same as with e to the power of x. If this was e to the x, this would be the natural log of e times e to the x. But the natural log of e is 1, so it's just e to the x. So this generalization works and is consistent with what we already have with the e to the x rule. So that's all you do for this. And for something like the log base 2 of x, this will just be 3. Since this is a base 2 logarithm, we're going to put the natural log of that base down here, and then x. I would say that in a lot of calculus type of problems, we don't really use these rules as much. So I don't want to say that this is a rare rule that you're never going to use, but I would definitely say that this is less common. And of course, the reason for that is because a lot of these rules, it's just kind of a differing by this constant. And it actually demonstrates that we prefer to use the natural log and the natural exponential function. So it almost becomes unnecessary to use other bases once we have e to the x. But again, this rule does allow us to take derivatives with other bases. So that is it for this video. As always, I hope that you found this video helpful, and take care.